Hi there. Uh, what I'm going to be trying to do is to repair a German sewing machine called a PFAFF. In particular, it's called a PFAFF 1222. Now, this machine began manufacture in about 1968. However, this particular machine is probably younger than that. It may be 1970, 1980. However, the machine is old. Today it's 2024. So my wife went across to see a friend of hers who had this machine, and they began looking at see if they can get it to work. It did. It started to work particularly well. And after a little while, without touching it, it seemed to go pop. Now, I don't know what sound that was it made, but that's the sound that they said it made, and it wouldn't work. The machine in particular is this one, the PFAFF 1222. It's not the PFAFF 122 electric, it's a very simple machine. So I decided that it was worthwhile having a go at fixing it. And what I've done is to take the machine apart. I thought originally it was the power switch, the little red button switch that turns the machine on and off. And it controls the light as well as the mechanics inside. So when I originally took it off, I took the switch off and the switch was broken. So I thought really this was the reason for it not working properly, and it would be easily to repair. The spare parts for this machine are not easy to come by. However, when I took the parts out, I found that in particular, the large capacitor, which is an ancient capacitor, had blown. I have taken various photographs in between, and I can show you the stages at which I am busy repairing this machine. So far, I have ordered a new switch, not identical to the original switch, but a switch anyway, which should work, a fuse, which was on the PCB, and also a new capacitor. Now, there are other things on this PCB which could cause problems, and I don't know whether that's going to be the case or not. We've decided to call my friend around and discuss the possibility of purchasing other things to make it work. However, I may be able to get it work in time. So what follows is a series of stills showing the various parts that I've been able to take apart, which allows me then to put it back together again and see whether it works. This is the machine. Hope you enjoy the recording. Well, this is a PowerPoint presentation that I'm doing just to cover some of the overheads, just to describe exactly what I'm doing. And it shows parts of this machine, which is a 1222, a PFAFF, and the picture here is really from the instruction manual. And I show it just because of this thing here, which is the switch. It's a red button, and this activates the lamp and also the mechanism for starting the machine. And we'll find later on that when I show you, this switch has been damaged and broken. This is the serial number of the machine which I'm dealing with. It's machine number 301-92970. It also shows that it's a type 1222 240 volt 80 watt. This picture is also taken from the instruction manual and shows the essential parts of the machine. The next slide shows the underside of the machine base plate below the red on-off switch, which is here shown as number 12. We're dealing with something underneath this box here. And this is a diagram showing the underside of that base plate, and it's showing the mechanism here, but in fact the PCB which sits here is not shown in this diagram, although the switch hole is shown just here. And this is a photograph I took of the underside of the base plate. It shows the PCB circuit up here, which is in a vertical position, and it shows the connectors attached to the PCB. This on the side is the 4-pin socket, which powers the PCB and therefore the motor as well. And here's a close-up of the PCB with all the connectors here. There are quite a number of connectors, and just below you can see an N and an S here, and this I'll show later on. This bit of plastic highlights all the numbered connectors along here. This is the surface of the PCB showing the blown capacitor and the fuse. Here's this large capacitor. I think it's 2 capacitors in one, and definitely showing a blowout here. And because of that, I believe we also have this fuse, which I found is a 2 amp fuse, a fast acting fuse. And this I tested, and this was also blown as well. So there's 2 components I know are faulty. What I don't know is whether any of the other components on this board are damaged. I've shown this as well. I've taken the board out, taken all the connectors off, and this is a 3D image of the PC board. This is a position here which I will be putting a spare fuse. The blue cables here are actually attached to the socket which is powering the machine. The black cables here are really to do with the switching mechanism. This is a plan view, if you like, showing more detail. What it does show is I didn't notice before, but it highlights what the fuse is sitting here. It's a 2 amp fuse, fast acting there. This position here is where the large capacitor, the failed capacitor, sits. The 2 components here, the 2 legs and the single leg here. And this is the plastic piece that sits in between the connectors, and it shows the number of the connectors, 1, 2, 3, all the way up to 8 and 9. The S and N, I'm not sure what these are for, but the holes here allow you to put a screwdriver in and tweak something. What it tweaks, I'm not too sure about. This is in a large picture of the failed capacitor, and no question at all that this is blown and may have caused this damage to the machine and stopped it working. I did find a replacement for this capacitor in a very interesting company started up by a gentleman who lives in Norway and is an expert on sewing machines, and decided that he couldn't find replacements, and in fact he was very good at 3D printing. And he took the board, and especially this capacitor sitting here, and he 3D compiled this thing here. It is a 1 by 0.1 microfarad and 2 by 2200 picofarad. I have ordered one of these to replace the existing capacitor. The fuses I got from Amazon, and again you get 10 fuses for about $3.95. This shows the old fuse, obviously dirty and blown. This is the new fuse which I shall put in. I did find, interestingly, a circuit diagram of the PCB, and this is from a thread in a website which is shown below here. If you click on this website, you'll find a trail showing that somebody is trying to do the same thing, repair this PCB. In other words, or trying to replace this whole PCB with a regenerated one. This diagram was on the thread as well. Also, there's another diagram by Clive Judd in response to a question by Dan Kim, and this is a handwritten version of the diagram of the PCB, and this can be found in this website should you want to have a look at it. I am not too familiar with circuit diagrams. I do recognize components on it, but I am not an expert in this field. I mentioned the switch in the beginning. This is the switch. 3 pictures of it, really. I have tied cotton thread to one of the limbs here just to make sure I know exactly where to fit this back into the switch. The blue cables here are power switches which go to the socket. In particular, I have ordered a new switch which is not identical to this, but would seem to work. This is the socket showing the power cables running in there. I have marked them so that I can put them back in the same position. And these are the connections for the switch. I did take pictures of the underside of the PCB showing exactly where the connections for the new capacitor will go, here and here. The repair. Now this is the PCB with the attached 3D printed capacitor. I've soldered on the terminals, these 2 here, and the 3rd one over here. And a closer view of this shows the PCB, capacitor underneath, and these are the terminals that I managed to solder on. The soldering job was quite okay, actually. So now this is the completed board. What we have here is the fuse, the 3D printed capacitor, and all the rest of this PCB, all the components on this board are in fact as they were. These at the top are the terminals, which you'll see later. The blue are the power cables, the black here are the switch. The next one shows how I've put the PCB inside the box which it came in. This was a tight fit. Here you can see the switch, which is upside down. This is the top of the switch here. The switch itself was broken, but in fact what you can do is to turn it into a on position permanently, and then I superglued the white part back onto the switch. At some future point I know I can replace this switch as a permanent feature and a proper one. This fuse is here. You can just see the capacitor just hiding underneath here, and at the moment the power cables, the blue ones, are not connected to the socket. This will be done in the next slide. Now here we have the completed encapsulated PCB with connectors. This is a plastic plate that goes and covers the PCB components. The switch can be seen here. The power cables go through here, and I've managed to solder on those to the socket itself. So this now needs to go into the machine. Here we can see the machine in its completed form, the PFAFF 1222, and at this point when I put this on the table I had no idea whether it would work or not. Here you can see there is no red top switch, because what I needed to find out was whether the machine worked or not using the switch in a permanently on position. In other words, I can use the machine by taking this out and in depending upon how I want to use it. The switch can be obtained. I know I can obtain a proper switch in due course, but I need to know whether this machine worked or not. So the question is, does the machine work? Well, yes it does. So I will show you a little very short video on the machine itself, showing the light and also very slowly showing the needle going up and down.